Hi everyone, this is the first video for section 6.3 on multiplying and dividing fractions. So we can use a lot of the same strategies that we used. We can use a lot of the same strategies that we used for whole numbers, that's what it is, in chapter 3, to look at our multiplying and dividing models and algorithms and those same things we can use for fractions. The first one we're going to look at is repeated addition. So when we multiply a whole number times a fraction, we can think of it just as this repeated addition problem, where 3 times 1/5 is just the same thing as adding 1/5 3 times. And then when we add 1/5 3 times, we just get 3/5. Whoops, sorry about that. We just get 3/5. Okay, and so that's represented here on the number line, where we first add 1/5, then we add another 5th, and then we add a 3rd 5th, and we get all the way to 3/5 here on a number line. Okay, the next thing we can do, well, this is how to think about it with a whole number times a fraction. So we're going to take some steps to work up to multiplying two fractions together. So this first way to do it, whenever we just do a whole number times a fraction, we just add that fraction that many times. And so we can see that the total length should be 3/5. So 3 times 1/5. 3 times 1/5 is equal to 3/5. So however, we can think of every whole number as a fraction by just having a denominator of 1. So we can think of this as really 3/1 times 1/5, right? 3 wholes over 1 part, which gives us 3 wholes. Sorry, that's incorrect. So if we have 3 parts, so if each of our wholes is just in 1 part and we have 3 of them, then we really just have 3 wholes. And if we multiply that by 1/5, we get 3/5. So we can see a pattern here to kind of work up to the multiplication algorithm for fractions. Well, that 3 times 1 in the numerators is 3, and 1 times 5 in the denominators is 5. So you can see how this kind of motivates the algorithm that we all know, that to multiply fractions, you just multiply straight across. So we can see why this works for whole numbers. So now let's start to think about multiplying a fraction and a fraction together. So what does it mean if we're thinking about this in terms of models? So kind of similar to what we just did. Instead of thinking about 3 times 1/5, let's think about 3 times 1/2. So if we think about it in this repeated addition model, this is 3 pieces of length 1/2, or just 3 halves, right? We just have 3 times 1/2 means we have 1/2 3 times, so we just have 3 halves. However, if we think of it instead as 1/2 times 3, then we just have half of 3. And so these give us 2 different pictures to kind of visualize. We can either take something with 3 and only consider half of it, or we could think of having a value 1/2 3 different times. But we know, based off the commutative property of multiplication, that these are going to give us the same value, but we have these different ways to think about it. So let's think about the case where we have 1/2 of 3. In this case, we can have a box of length 3. So I'm going to go ahead and trace this just so we can see where the 3 different pieces are. Okay, so we have a box with 3 rectangles here. And so the first step of looking at this, so I'm going to write steps of how we can visualize this multiplication. So the first thing is to draw a box of size 3. The second thing to do is find half of the box and shade it. So that's already been done on this picture. So we have this dotted line that helps us to determine what half of the box looks like. So we find half of the box and then we shade that. And then we determine, to just find what 1/2 of 3 is, we determine the size of the shaded part. So we determine the size of the shaded, let me rewrite that a little bit, the size of the shaded part. So in this case, we drew the box of size 3, we already have it shaded, but now we need to know how much is the shaded part. Well, if we're looking at it, we know that we have, right, this whole one of the parts out of the 3 is still completely there. But then this middle one, we don't have that hole. We don't have all of that hole. We just have half of that hole right down the middle here. So we have one hole and then half of another. So that tells us that 1/2 times 3 gives us one hole shaded and half of another one shaded. So this gives us 1.5. Okay, so what does this mean? That whenever we think of 1/2 of 3, we just get a fractional part of 3. So similarly, if we extend this to multiplying a fraction times another fraction, when we do 1/2 times 1/3, we should get half of 1/3. So we get a piece of a part. So in this case, 1/3 is the part, right? Because it's one part of our whole. And then we just want to look at one specific piece of that part. So that's what essentially multiplying fractions means, is that we're looking at pieces of parts, where part comes from fraction representing a part to whole ratio. So piece and part. So it's exactly just the same. If 3 was our fraction, 3/1, right? That is still a part to whole ratio. But whenever we find half of 3, then we're finding a fractional piece, half of that 3 parts of our one whole. Okay, so the main takeaway here is that whenever we think about fractions, we're finding a piece of a part, because a fraction's already a part of a whole when we're just looking at a specific piece of it. So we're going to look a little bit more about how to do this operation, 1/2 times 1/3, in the next video.